Okay, this one we're going to discuss something called piecewise functions. This is where we're graphing a function that follows different rules in different areas. For instance, this will be piece number 2 because it goes up to x equals 1. This is piece number 2 because it goes after x equals 1, including 1. Okay? So piece number 1, x is less than 1. The boundary point is at x equals 1, by the way. Okay? We use open dots at strict inequality signs. Okay? And otherwise we graph normally. Okay? Y equals 2x minus 6. So at x equals 1, we have y equals 2 times 1 minus 6. So 2 minus 6 is negative 4. So we have 1, negative 4. So we're on the number line, negative 4 will be my up down, and that's the end point of piece number 1. Okay? This is a line. Okay? So we only need 2 points for this one. Okay? So let's go back a little bit. X equals 0. So here's 1. Here's 0. So if x equals 0, y equals 2 times 0 minus 6. 0 minus 6 is negative 6, so we have 0, negative 6. We'll graph that like we normally would. Okay? And I suppose I can move that one down a couple more units. And finally, how about, so we did 1, 0, let's do negative 1. So y will equal 2 times negative 1 minus 6. Because remember, we're following this rule in piece number 1. So that's negative 2 minus 6, negative 8. So negative 1, negative 8. Negative 1, negative 8. It's a line. So we'll just put the line through. For that end. Okay, piece number 2 is for x is greater than or equal to 1. Okay, that's going to be a closed dot. Because of the or equal to. And the rule is y equals x squared minus 3. So for x equals 1, we have y equals 1 squared minus 3. Which is 1 minus 3, which is negative 2. Okay? So the point, the boundary point will be 1, negative 2. So, 1 the number line, negative 2. Okay? How about x equals, moving right along, let's do x equals 2. Y equals 2 squared minus 3, because we're following this rule here. 2 squared is 4. I get 1. So the point is 2, 1. Okay, so 2, 1. And let's do another point. X equals 3. Y equals 3 squared minus 3, which gives me 9 minus 3, which is 6. So 3, 6. It's going to be a curve. It's a parabola. It's quadratic. So it's going to look something like that. And that's how you do a piecewise function. Okay, let's do example 2. F of x equals six minus x squared. Well, why don't we do it this way? 6 minus x squared. I'm going to do 3 pieces. 6 minus x squared for x is less than or equal to negative 1. X plus 1. How about x? We'll do x plus 3. X plus 3 for x is between negative 1 and 2. And then it's just negative 7 for x is greater than 2. Okay, here goes. There's actually 3 pieces. Piece number 1. X is less than or equal to negative 1, and that's going to be a closed dot. So, x equals, if x equals negative 1, okay, because these are boundary points, negative 1 and 2. These are boundaries, negative 1 and 2. So for piece number 1's boundary, we have x equals negative 1. We're going to do 6 minus negative 1 squared, which is actually 1. So we have negative 1, 5, and because of the or equal to, it's going to be a closed dot. Okay, that's negative 1, 5, closed dot because of the or equal to. All right. So then we're going to go over to the left. So we'll do x equals negative 2. It's a little bit over. 6 minus negative 2 squared. So here's the boundary where we're going to go this way. So that's 6 minus 4, which is 2. So we have negative 2, 2. Okay? And then for a good measure, we did negative 1, we did negative 2, let's do negative 3. 6 minus negative 3 squared. 6 minus 9 is negative 3. So we have negative 3, 3. So negative 3, negative 3, that's negative 3, negative 3. So negative 3 on the number line, down 3. It's a quadratic, so it's going to be curved. Okay, so that's piece number 1. Piece number 2. Negative 1 is less than x, which is less than or equal to 2. That's going to be an open dot. That's going to be a closed dot. Okay, so at x equals 1, we have, by the way, the rule in piece number 2 is that y equals x plus 3. So y equals, so here's the first boundary point, x equals negative 1. So y equals negative 1 plus 3, which is 2. So negative 1, 2. That's going to be an open dot because of it's not or equal to. Okay, let's do another boundary point. X equals positive 2. Y equals 2 plus 3, which is 5. So we have 2, 5. So 2, 5. That's a closed dot because of the or equal to. Okay? In between. In between we have x equals 0. We have x equals 1. Okay? So y equals 0 plus 3, which gives me 3, so we have 0, 3. Here, y equals 1 plus 3, which gives me 4. So 1, 4. It's a line, which is what we were expecting. So we put a line segment through. Finally, piece number 3. At piece number 3, we have x is greater than 2. Okay, and the rule is that's going to be an open dot because it's not or equal to. And the rule is that y equals 2. I'm sorry, y equals negative 7. Okay, y equals negative 7 for piece number 3. Okay, so when x equals 2, y equals negative 7. So we have 2, negative 7 with an open dot. 2, negative 7 with an open dot. Going to the right, x equals 3. Y equals negative 7. So now we will have 3, negative 7. Okay, let's go one more. So here's 3, negative 7. Okay, so 2, negative 7 with an open dot because it's a boundary point. 3, negative 7. And then finally, let's go one more into piece number 3. And that's y still equals negative 7. So 4, -7. It's a horizontal line. Which we'll draw as a rect, because it has an endpoint. Okay, that's it. That's how you do these.